Okay, let's go ahead and get started with today's webinar. First of all, good morning, everyone, and welcome to today's event. Our webinar series is called Waste Heat Bottom Line, presented by ElectraTherm. This is our second webinar in a series of webinars in which we'll be presenting ideas and concepts related to how waste heat recovery can deliver bottom line benefits. On behalf of the team at ElectraTherm, thank you all for joining us here today. My name is Fariha Amin, Technical Sales Manager at ElectraTherm, and the topic of today's webinar episode will be methane reduction and enhanced energy outputs for landfill gas operators. Before we jump into the presentation, I'd like to take a moment to go over a few items so you know how to participate in today's event. The audio and video feature has been disabled for attendees, but the chat box will remain open throughout the presentation. You will have the opportunity to submit text questions to the ElectraTherm team by typing your questions into the chat box of this event. You may send in your questions at any time during the presentation. We will collect all your questions and address them during the Q&A session at the end of the presentation. Upon conclusion of the webinar, if you'd like to have a copy of the presentation slides or a copy of our webinar video, please feel free to send us an email at sales@electratherm.com. Otherwise, we'll also be going ahead and posting this content to our website in a couple of days. With that being said, I'll hand it off to our featured speaker for today's event, ElectraTherm Sales Director for Renewable Energy and Sustainability Strategies, Natalie Van Dyke. Okay, off to you, Natalie.
Good morning. Thank you, Fariha. Good morning and welcome to everyone. I appreciate you taking time out from your busy day today. We know that time is a resource, and we do not consider this to be a renewable one. It's one that you have in very limited amounts. So thank you for valuing us enough to spend time with us today. As Fariha said, my name is Natalie Van Dyke. I'm Sales Director for Renewable Energy and Sustainability Strategies here with ElectraTherm. I'm very excited to be speaking with you and looking forward to talking about methane reduction and the enhanced energy outputs for landfill gas operators. So with that, we'll get right into it. Oops, let me get that out of the way. There we go. First off, with regard to just a little bit about ElectraTherm, okay? We were established in 2005. We are a global leader in low temperature waste heat recovery. We provide simple and effective solutions that boost efficiency while reducing energy costs and emissions. By using organic Rankine cycle along with proprietary technology, our heat recovery system generates up to 150 kilowatt hours of clean electricity from heat sources as low as 70 degrees centigrade. Okay, there are no additional emissions or fuel consumption, and the power generated is ready immediately. ElectraTherm's heat recovery solution is modular, scalable, and robust, so you can use them whenever, however you need to for your application, okay? We were established in 2005, but in 2016, ElectraTherm was acquired by the Bitzer Group, which is a global corporation. It's the world's largest manufacturer of refrigeration compressors and a centerpiece for our waste heat recovery technology. You can actually see that here. This is a version of what you'll see inside of our equipment. It is a semi-hermetic twin screw expander. It is manufactured by Bitzer, so there was a lot of crossover synergy there, and it makes great sense for us. Bitzer is, as a corporation, is represented across the globe with 3,400 plus employees, sales approaching €1 billion annually, and the combined advantage of ElectraTherm's engineering, along with the value of being supported by such a large, reputable company as Bitzer, has allowed ElectraTherm to dedicate our energy and resources to the continual improvement of our product and the innovation of our proprietary technology. It's really a nice marriage of ideas and has worked well. So we're very excited by that and love that level of gravitas. With that said, after years of research and development, the very first power generator from ElectraTherm was successfully commercially released in 2011. And since that time, ElectraTherm has achieved a global reach. They did that before Bitzer was involved, quite frankly. But with Bitzer, it has gotten even further. We are not a Johnny-come-lately company. We have a strong history of successful implementations across multiple types of heat recovery around the globe. You can see on this this slide, this is actually an older slide. We're operating in excess of 13 countries, and we're 1.7 million operating hours in excess. We're well in excess of that now, and we're very proud of that track record. All right, so now enough of that, and turning to landfill gas, which is what everyone came here for today. Landfill gas operations specifically, I'm confident everyone on this call is aware of the more than impressive growth in this business sector over the last decade and a half, which is driven in great part by the demand in the state of California as related to the California Air Resources Board and the low carbon fuel standard. You can see here we have a map of the EPA's landfill methane outreach program, candidate sites for new landfill gas capture projects. As extensive as the growth has been in the last decade, we can see there is a great deal of work which can yet be done with regard to methane capture and, as a result, waste heat energy generation. So this is a market sector that is just, pardon my pun, on fire. But it is going to get nothing but larger, and the opportunities are impressive. Now, we have to give one moment to talk about the boogeyman in the room here, and that is CH4, methane, okay? Flare elimination is a problem for landfills, but it's also an opportunity, okay? You see here we have a outset or a excerpt from the Wall Street Journal. This is from May 31st. This is very timely, okay? The EPA rules are expected to be finalized within the next year and would affect hundreds of thousands of wells, storage tanks, and natural gas processing plants, okay? When the new monitoring requirements are expected to go into effect is 2026. That's very soon, okay? Flaring is the open air burning of natural gases, principally methane. We know this, okay? Commonly occurring in biogas production, wastewater treatment, during oil extraction. We know all this, okay? It releases large amounts of greenhouse gases that are major contributors to global warming, but mostly it's a waste of a natural resource, okay? But historically, due to the difficulty associated with storing and transporting natural gases, the easiest choice rather than utilizing it has been to burn it off. Okay, the establishment of a robust RNG market through CARB, though, has largely and happily shifted the economics of this. Okay, flares are still present in many locations, though, and recent government programs incentivize the reduction of flaring while beginning to impose fees for those violations. Okay, capping the flare is difficult, or it has been in the past, but it has become economically feasible. Okay, you're able to avoid negative impact on the environment and the health of nearby areas. It's a very, very positive outcome all the way around, as far as ESG, as far as finances, and as far as your stewardship as a corporation in your communities. Now then, how does ElectraTherm fit in with that CH4 flare capping strategy? Okay, how can the unused natural resource of the flare become an asset? One answer is, of course, utilizing an ElectraTherm organic Rankine cycle generator for heat recovery and electricity generation. How does it work? Well, it's exactly as we show here on the graph. It's very simple. You have a hot water stream in, goes through. The ElectraTherm's heat to power cooling solution utilizes a closed loop ORC to convert excess heat into electricity. You take the hot water in, and then you get electricity out and cold water out. It's that simple. That's all there is to it. Okay, very simple technology, not a lot of moving parts, low potential for failure, very reliable. Currently, ElectraTherm has power generators sizes capable of 75 kilowatts and 150 kilowatts respectively. Each is available with or without an active cooler if additional cooling is needed, and or elimination of an existing energy inefficient cooling strategy would be beneficial. Let me say that again. It can be available with an active cooler if an additional cooling is needed and you have the ability to eliminate an existing energy inefficient strategy. We're going to see that a couple times today, okay? With regard to those sizes, though, for the 75 kW and the 150 kW, stay tuned. We have upcoming announcements on power generation capacity updates. We're currently in the testing stages for some very exciting new products, which will become available in the near future. And we will no doubt be announcing those developments in a future webinar event. So stay tuned for that. Okay. With regard to landfill gas projects, there are 3 types of landfill gas projects commonly seen, and ElectraTherm power modules may be incorporated for zero emission electricity generation in all 3. Zero emission, all 3. Lots of opportunity, okay? Project type categories include, we see electricity generation, okay, which generally includes engines, turbines, and cogeneration. Direct heat use, okay, that was a terrible circle. Oh my gosh, okay. Direct use, including medium BTU technologies such as boilers and other direct heat applications, direct thermal usage. And finally, renewable natural gas, okay, including the options to sort by delivery method. That would be either pipeline or injection for local use, okay. All 3, again, can utilize an ElectraTherm unit to produce electricity, which can be used on site or sent to the electric grid. There are, again, that can be on site or to the electric grid, depending on your needs. But I'm going to make a case today that using it on site has some very valuable opportunities that I think you're going to be impressed with. Okay, just to cover these quickly, we have, to begin with, we have the engine turbine cogeneration application. Okay, here you see a schematic for how that architecture would generally work. You have two potential sources of heat from the engines, which may be exploited. Okay, you have your heat exchange, exhaust gas heat. Okay, as well as the cooling jacket water. Okay, those both connect, you see, to our ElectraTherm system. Okay, and you can get heat rejection through an exterior radiator, should that be necessary, with the active cooler, which in this instance would replace your existing engine radiator. Okay. Additionally, this traditional engine application presents an opportunity for ElectraTherm's active cooler, like I just said. Okay, and you can replace the massive radiator. Okay, here, replace your massive radiator while actively exporting power. In short, the active cooler replaces a parasitic load of the radiator and generates electricity rather than drawing electricity. So what was previously a cost center to you becomes an opportunity to create zero emissions energy. It's very exciting. Again, you are offsetting the largest parasitic load of that engine. Okay. Here is an on-site graph or image showing the ElectraTherm power generator plus an active cooler. It's cooling the active jacket water in lieu of a radiator. Here's the size of the system as composed to a natural gas compression site. This is a natural gas site, but it is what is very similar to what you would see at an RNG location. So I wanted to put this here so everyone could see exactly what it would look like. Okay, moving on to the second type, we have direct thermal cooling circuits, okay, as an opportunity. Here we also have a schematic. This shows boilers. Boilers are extensively used to provide heat to biogas and wastewater treatment plants. I think we know that, okay. Boilers only work for a small portion of the time when the site calls for heat, okay. They're only using that when it is part of the biogas or anaerobic digester process. They create that heat. However, once you add an ORC heat recovery system, such as the Power Plus, okay, or an active cooler, it produces power and consumes hot water 24/7. So you can utilize that expenditure of that capital piece of equipment, that boiler, now becomes an asset that you're able to use 24/7. It is not encumbered by the same downtime. Okay. By increasing the hot water production, power output can be maximized and flares can be 100% eliminated. That is fantastic. I'm going to say that one more time. You can increase your hot water production, your power output is maximized, and the flare is 100% eliminated. This not only reduces emissions, but it creates a sustainable base load of zero emissions power supply. You can see here your biogas source. We have a flare, which is where it would have gone to historically. It is not going to do that anymore because it is going to power your boiler, which interfaces with the ElectraTherm system and your cooling option should you have it. This gives you all the benefits that you would want. You're able to create that power long term. Okay. Here's an example of an application we have doing exactly that. This is a really exciting opportunity. This is Port Richmond Water Pollution Control Plant in Staten Island, New York. I had the opportunity to visit this site just last week. I took these pictures myself. It was very great. It was a good day. These are brand new boilers. They are use a combination of biogas from the wastewater treatment facility and natural gas. They replace equipment dating back to the 1970s that ran on heating oil. So this was a very substantial upgrade for them. By capturing the flared biogas and using it in the plant's operation, and they're lowering the reliance on fossil fuels. All of the energy is being consumed on site by the facility itself. They don't export anything to the grid. Everything is used on site. And the greenhouse gas emissions are being significantly reduced. The facility's relationship with the neighborhood particularly has vastly improved as a result of the reduced environmental impact. They were able to cap a flare, made the community very happy. They're extremely happy with this operation thus far. It was commissioned very recently, but the ElectraTherm project is actually being evaluated as a case study for potential future implementation at additional New York City metropolitan waste and water treatment facilities. So what we have here is a good start and a lot of potential for expansion. As I said, I was there last week. They're extremely happy with this setup. This is another image of the same facility. You can see City of New York. The image simply illustrates the scale of our equipment size. I like the scale here. The footprint is extraordinarily small. In this image, you can see it's right here. You can barely see it. All of this area is the rooftop of the facility, and it takes up just the smidgiest small part right here. And this unit right here, just you can get a perfect scale. The gentleman in this picture is from Sherwood Logan. He's a very nice person. He's a partner of ours in the system, and he's about 5'8". So that tells you exactly the size of the equipment that's here. It does not take a large footprint. It's very scalable, very modular, very easy to find a location to create this type of energy at your facility. There you go. This is, again, where it is very tiny. Okay, now, finally, moving to type 3, which is the one that I'm sure most of us are here for, the renewable natural gas pipeline option. Here we have a schematic that shows a thermal oxidizer, which are either present or planned at many landfill RNG origination sites. They are an extremely good heat source opportunity for ElectraTherm power generators. And again, the active cooler is available as a cooling option should that be needed at your location. Additionally, any style of existing or future candlestick flare associated with the RNG to pipeline architecture, for instance, off your waste gas, anything that cannot be cleaned up enough to go to the pipeline, anything associated with that, the architecture is also an opportunity for heat capture and electricity generation, similarly to that described in the type 2 direct heat capture topic. But here you see a thermal oxidizer, okay, which interfaces directly with the ElectraTherm unit, and you have up to 150 kilowatts of output. I want to keep that in mind. Every unit that we generate, or every unit that we make, or individually, has up to 150 kilowatts of output within the space that I just showed you in the previous slide. So we've covered that. Now we're going to RNG operations specifically. What are the benefits of ElectraTherm to your landfill or wastewater treatment? You get it. You get it. You can do it. It's possible. What's the benefit though? Aside, where does the economics come in? Here's where we are. Okay. The state of California. Almost everyone knows this, but the state of California is the market the vast majority of renewable natural gas and biomethane manufacturers are working to reach. And the reason is, of course, the credits being given by the California Air Resources Board, sometimes often referred to as CARB. Okay, and this is part of the low carbon fuel standard, which is also referred to as LCFS. There's a lot of acronyms. I apologize. RNG has become an incredibly lucrative resource as a transportation fuel in California. Okay, you can see in this graph the biomethane production represented in the dark orange band. Here's your dark orange band. Okay, has increased year over year since 2014, and the amount of carbon displacement accredited to biomethane reached nearly 2 million metric tons in the year 2020. That's approximately equivalent to 250 million gasoline gallons of transportation fuel. That is a lot of RNG being used as transportation fuel. Now, why? Why are we using RNG instead of, or why is California using RNG instead of gasoline? Certainly not because it's easier to get, okay? But the reason is carbon intensity and the carbon intensity score. A carbon intensity is the emission rate of CO2 by a given pollutant, in this case automotive fuel, relative to the intensity of a specific activity, which in this case is transportation. This is the data that California is making all of these decisions on, carbon intensity. Okay. The price in dollars of gasoline gallon equivalent of alternate fuel is inversely proportional to the carbon intensity of that fuel. I'm going to break that down for you. So the lower the carbon intensity your operation's RNG fuel is, the more it will be worth in the market. Okay. The lower the carbon intensity, the greater the low carbon fuel standard credit value. This is a difficult thing to understand for some people. We're going to go through it slowly. If you understand it already, I appreciate you sticking with me. Here we go. This graph is very small. Okay, I'm going to curate it for you for a moment. The left-hand column here, okay, this shows the carbon intensity scores. Okay, it's also referred to as a CI score. They range from a negative 273, okay, up to a high of 180 at the bottom. Minus 273 is here, 180 is here. The top row here indicates the credit prices and shows values ranging from $196 per metric ton up to $200 per metric ton. Metric ton of what? Metric ton of carbon displaced. Okay. On the cross-reference intersections here of the X and Y axis is the value of the fuel in gasoline gallon equivalents. So each one of these numbers represents what you would pay if you were buying gasoline. Okay. In this instance, we see that the lower the CI score, the higher the reimbursement rate under the LCFS, low carbon fuel standard, the higher your credit. The payments for low carbon intensity are higher to your operation, to your corporation, if you can get that carbon intensity down of your RNG that's being produced. Okay. Moving on here, the question then becomes, how is carbon intensity calculated? We've already established that having a low carbon intensity is good. It's worth money to you for your RNG to have a lower carbon intensity because you're going to get a higher LCFS reimbursement. But how is the carbon intensity calculated? As many of you know, it is assigned by the California Air Resources Board using a calculator called the Greenhouse Gases Regulated Emission and Energy Use in Transportation Model. This has been shortened to the very sexy name of the GREET model, G-R-E-E-T, okay? And here we have an example of it. You can see each separate fuel has what's called a pathway and its own calculator. What we're looking at here is the biomethane landfill biomethane pathway. You can see that here, okay? Each of the calculators is not quite as difficult to navigate as the IRS tax code, but it still has its own impressive levels of complexity, truly. Here we have the main page of the biomethane pathway calculator, okay, which is utilized to determine the carbon intensity of this fuel source. And you can see circled here, there is a value called electricity kilowatt hours. That goes into the calculation, electricity. Where does it go into the calculation? Goes over here, okay? This is the production, section 2 of the biomethane production data, okay? Landfill biomethane calculator is the amount of electricity, it shows here, section 2.9, the amount of electricity from the grid being used by a landfill facility. Landfill facility, that's difficult to say. Say that one more time, landfill facility. This is a value that you have to enter. Someone in your accounting department, somewhere in your operations, when they fill this out so that they can get their RNG application and start selling your fuel to the carbs, into the carb system, they have to fill this out. They're probably going straight to an electric bill somewhere, pulling out the data, putting it in, moving on. Don't think any more about it, okay? However, the electricity from the grid adds to the carbon intensity total of your biomethane fuel. This is an adder to your carbon intensity number. And we already know a low value carbon intensity number is what we're seeking. So it would follow anything you can do as a facility to reduce the total kilowatt hours usage from the grid would contribute to a decrease in your carbon intensity score. Carbon intensity, the score impact of zero emissions, heat recovery power. How much of an impact is it? Fantastic question. And one, quite frankly, we too would like to explore, okay? The GREET calculator, which we've just looked at, has many inputs, and it's not clear how each is weighted. It's very likely that some of the values are weighted more than others. So to give you a clear answer would be disingenuous. I don't want to be disingenuous. We never want to be disingenuous. But it obviously, any energy that you can create and use on site that you are not getting from the grid is going to go into reduction of that carbon intensity. Okay, in order to determine the delta between a before and after, it's necessary to understand all of the real world variables though in play at any particular landfill or wastewater facility. With that being said, if anyone on this call today is interested in working through some calculation differences with us, we would be very happy to collaborate on this and define exactly how much benefit your CI score would be generating from heat recovery, okay? Pardon me while I take a drink. Okay, I'll say that again. Okay, we would really be very happy to collaborate on this and define exactly how much benefit your CI score would see through the generation of energy on site through heat recovery. It's going to displace the kilowatt hours, which would otherwise need to be purchased from the grid. We know there will be an impact. If you would like to call us and work through it together, we would love to do that and see exactly what impact it would have on your overall CI score. Okay. With that being said, we are at the 30-minute mark, right on. I am going to turn it back over to Fariha. I thank you very much for your kind attention, and any questions that you have at this time, we would be very interested in discussing with you.
Thank you for the really interesting presentation, Natalie. There's so many great opportunities that we have to utilize ORC technology for these methane reduction applications. Like Natalie mentioned, so at this time we'll be taking questions from the audience, so please feel free to use the chat box to post your questions if you haven't had a chance to do so yet. So let's go ahead and wait a second, and looks like we're getting some questions coming in. Okay, here's a question from one of our audience members. What is the maximum power that you can offset from the grid annually?
Okay.
Natalie, like to take this one?
Yes, I'd be happy to. That's a fantastic question. Thank you very much. The truth is, it is very much a function of your available heat sources, your available space, and the number of places we can tie in. I said before, the systems that we have are modular and scalable. So one unit, although we can create up to 150 kilowatts of power for one unit, there is nothing that states that if you have additional usable heat that we cannot use additional units. So for instance, one application that we analyzed recently had, I believe, 6 potential systems on that location. Can I say that across the board everyone would be able to do that? No, that's not how it works. It's really a function of how much heat you have, and we need to do that analysis for you. With that being said, we're happy to have the conversation. We're able to turn those analyses around very quickly with the expertise of our team, including Fariha, who is here today. It's very much a wide open question and one we look forward to exploring with you. Fariha, do you have any additional thoughts on that topic?
No, like Natalie mentioned, yeah, we would be happy to explore. It will depend on, the particular the parameters of your application. So yeah, if you would like to get in touch with us directly, we'd be glad to look at this further with you. So let's take our next question. So our next question is, how many BTUs are required to generate 1 kilowatt? I can go ahead and answer that question. The minimum output from one of our units is 5 kilowatts. So, and in order for us to evaluate how much you'll be making from your particular application, as we mentioned in the last question, it would be great if you could get in touch with us directly. We can walk you through the parameters that we need to assess to see how many kilowatt output you'll be making. And for further information on this, yeah, please feel free to email us at sales@electratherm.com, or we can also arrange for an informational call as well after the event. So yeah, please get in touch with us to discuss this further. Another question, how long can a unit run nonstop? And I can take this one as well. So our units are able to run pretty much 24/7, except for the very minimal maintenance work that's required, during which the unit will have to be downtime. But we have a very great fleet availability across our entire 100 plus ORC units worldwide. We have a fleet availability of about 98%. So our units are very robust and reliable. And we can also share further information about the exact numbers, how many hours downtime are required for maintenance after the call as well. Another question we've got coming in. Hello, what is the lead time for an ElectraTherm unit? So that's a really great question. So currently, we aim to have a standard lead time but currently, due to fluctuations in the supply chain, lead times can be a little bit variable. So it would be best to contact us directly, and then depending on which ORC model you're looking at, we can give you a better estimate of the actual lead time at the moment. Let's see. Oh, getting some more guests coming in and joining us. Let's see. Okay, we're getting a few more questions coming in. It's just a moment. Okay, so the next question we're seeing is, what is the approximate cost of a 75 kilowatt unit? The total install cost will vary depending on what you actually need at your site. We of course require we'll have the ORC unit there, and then of course depending on the rest of the balance of plant and other project costs, that'll influence the total installed costs of the ORC installation. So it would, like I mentioned, these are the kind of questions that are really great for us to discuss when you submit a project evaluation to sales@electratherm.com or arrange a call with us. We'd be glad to walk through the entire project economics with you.
Yeah.
Natalie, do you have any comments?
Yeah, Faria, on that one, I do have one quick comment.
Yeah.
Thank you for the question. It's a great question.
Yeah.
Part of it, that sounds like, a dodgy sales thing. Oh, contact us, we'll give you a price. That's really, there's a lot of variability that goes into the pricing on this. And harkening back to the 3 types of applications that I just spoke with, we have a lot of different options available for each unit, whether or not it's an indoor unit or an exterior unit, whether or not you want to have sound dampening, what exactly options. So similarly to a car, we have a standard model, and then there are additional options. So pricing is very much a function of what's necessary at your location. We don't want to give pricing out of hand, because either it could look like we went too high and it didn't look right when you didn't need as much of that, but at the same time, we don't want to be considered in a position where we gave you a number that was too small, but your scope of delivery was well beyond that, and then it looks like there's a bait and switch. So just to be clear, clarify that we have the ability, depending on what the application is, to get it, laser focused on what your needs are. And then the pricing is associated with the takeoff from the scope of delivery.
Yep, absolutely. Yeah, thank you for that, Natalie. Yeah. So, let's take our next question. What if I'm interested but don't know how much heat we have? That's a really great question, and we're able to, depending on what heat source you have at your site, say it be an engine, a boiler, a geothermal source, we'll be able to guide you through the right questions to determine how much heat you might be have at your site. And we can also work with you through different iterations of your project. And as you have more data, we can also further refine our project analyses. And this is also something, we can discuss further after the call, and I'd be glad to help you evaluate, which ORC would be the best fit for your application and how much heat you may be generating from your particular heat source.
Fariha, I would add on to that also. We are, as I said, innovating all of the time, and one of the innovations that we have been expanding recently is our ability to be helpful to a customer in this area on a consultancy basis. If you have a heat source, for instance, if you have a methane stack that exists, but you're not sure how much heat is there, or you have a boiler and you're not sure how much available heat, unutilized heat, and you need to discuss that, or how much cooling you need, even if we're talking about if you'd like to displace a radiator or an inefficient cooling site. We do have the internal expertise to be able to come to your location and help you identify some of that when it's useful and it makes sense. So please keep that in mind also.
Yep, absolutely. Let's take our next question. So we have a comment from one of our attendees. We evaluated an application for ORC with the exhaust heat from an engine. At that time, the heat exchanger to get the heat from the exhaust was an issue. Has this been addressed? So yeah, thank you for your comment and your question. In regards to the exhaust heat coming from an engine, sometimes what is rated, what is listed on the engine data sheet, or what the customer is expecting from their heat source, it may not be due to the way the engine is sometimes configured. It could be that the amount of exhaust heat that you were expecting, or that had been that was listed on the data sheet, wasn't exactly the amount that was available for the ORC, and of course that would then affect the project output, or it could be something to do with the way the heat exchanger was configured. So that's just those are just some general comments. And of course, for our applications, whenever we look at heat recovery from exhaust gas sources, like Natalie mentioned, we can also, as needed, travel to look at your engine, how it's configured, to best assess your needs, and we can also walk with you through every step of your project to make sure that you are getting the heat, the amount of heat that you're expecting to provide to the ORC is actually what we're getting. So we're generating as much electricity as possible. So yeah, I would say, yeah, please contact us if there are any questions about this topic in general. We would be glad to help. Looks like we have another question. So let's see. So typically, are these systems economically feasible without economic help, like tax exceptions? Natalie, would you like to take this one?
I would be happy to take this one. Thank you for asking. The answer is it depends on what your value set is, quite frankly. When you say feasible, feasibility is in the eye of the beholder, and it has to do with your value set. At this point, there are so many corporations going forward with ESG initiatives. The SEC is getting involved at such a rate in checking scope 1, scope 2, and scope 3 expenditures. So what you consider economically feasible is quite often a function of what you are calculating as an economic cost. And going forward, as the SEC particularly mandates the reporting of greenhouse gas emissions and your carbon exposure and your carbon footprint at the corporate level, I would argue very affirmatively, yes, it is absolutely economically feasible, because the number of things that are listed in the cost column is expanding every day. Okay, and we are offsetting those costs. We are helping offset those costs, whether it be on your, as we talked about directly in the article or in the presentation today, whether it's by reducing your carbon intensity, okay, or if it's improving your ESG score. Those things are cost centers. And if you are calculating those costs in, I have every confidence that the cost of the ORC systems as what they bring to you is going to be considered a rounding error, quite frankly, going forward.
Yes, thank you for that, Natalie. Do we have any other questions at the moment? Okay. Okay, then. Oh, it looks like we're getting another one coming in. Oh, just, yes. Let me, okay, then it looks like we've addressed all the questions for today. Thank you all for the really great questions and your participation. At this time, yeah, we'll be concluding the presentation, but of course, please feel free to send an email to sales@electratherm.com if you have any other questions, or if you'd like any additional information about our products or our project analysis to evaluate your application. So once again, yeah, thank you all for joining us for today's event. We anticipate our third webinar for this Waste Heat Bottom Line series to take place on July 26th. So please mark your calendars for that day. And of course, please stay tuned for an official announcement from ElectraTherm at that time. Thank you all again. Have a great day, and we look forward to seeing you again at our next event. Take care. Bye-bye.